Hello everyone, this is Todd Hurt, Product Manager at West Penn Wire. Today I want to look at our unique indoor-outdoor Aquaseal water-resistant cables, and more specifically the dry water blocking tape that we utilize in our Aquaseal cable constructions, cables such as these. And we want to compare our tape to some of our competition that's using out in the field and referring to as a direct cross to our Aquaseal cables, and we'll see today that they are not a direct cross. You know, in 1990s, West Penn Engineering was getting frequent calls on providing cables for indoor-outdoor applications such as intercom, CCTV, fire alarm, audio, and many others. At the time, the only cables on the market were outdoor gel-filled cables. These cables did not have a UL indoor rating. The cables were gel filled with a sticky gel, and even though they are still in use today and do provide a great water blocking protection, these cables cannot be used for indoor because of the gel that's being used. That gel, the residue can get on your hands, get on your tools, get on everything that you touch. We looked at many alternative methods so we could provide it a UL indoor rating, but also provide a good water blocking barrier for outdoor in conduit or direct burial. You know, the dry water blocking tapes we found was a perfect fit for many of the applications that people were requesting indoor-outdoor cables for. Some advantages that the tape gives you: there's no residue on your tools, on your hands. It's not a sticky material. The tape is easily cut away when you're doing a termination. You can cut that Aquaseal tape away while you're doing your termination or doing your connectors. So we want to take a look at our table, how it expands compared to our competition. Taking a look at our 2-ply tape versus a 1-ply tape that a lot of competition is using out in the field. Our 2-ply tape, what that simply means is we have an Aquaseal dry water blocking polymer that is sandwiched in between two fiber filament tapes. A 1-ply that a lot of people are using is the Aquaseal dry water polymer is glued to only one side of a fiber filament tape. Now ours doubles the Aquaseal polymer. We can increase the amount or the volume of the dry polymer in between two tapes versus just applying it on one tape. Well, what happens when water hits these tapes, becomes exposed to these tapes, the tapes will swell. And on our 2-ply tape, our swell height within the first minute is 10 millimeters. The competition is around 5 millimeters. And this is a crucial point if there is a cut or a slit in the jacket that we want to fill any voids so we don't allow water to wick or transverse its way down the cable and disrupting any electrical characteristics such as capacitance and velocity of propagation. After 10 minutes, our cable swelled to 12 millimeters and the 1-ply tape swelled to 10 millimeters. Taking a look at this picture, you can see that a dry piece of water block Aquaseal tape, and then on the other side exposed with water. You can see the expansion rate and also see the water blocking dry polymer. When it's wet, it's swelled, and how it's sandwiched in between two tapes. There are two different ways we try to stop water from migrating way down the cable. First is transversal blocking. That's if there is a cut or slit in the jacket. The dry water blocking tape will absorb any moisture and swell with a rapid and dramatic increase in volume. The swelling fills the voids and provides a physical barrier against the water migration. So looking at this picture, you can see that a cable has a cut in the jacket and been exposed with water, and how it expands and filled the voids. Another way we try to stop water is longitudinal protection. This is the least of our concerns because we don't want the end face of the cable to be exposed in water, and it shouldn't be. These cables are good for direct burial and in conduit, but the end faces should be terminated in an enclosure or within a rack within a building. But looking at this picture, you can see how the end unexposed with water, and then we exposed it with water, and how it fills the voids there also.